Welcome to E-Padasala PG program for computer science students. So, in this model we will be looking at design methodologies. So, in this model we will be discussing about the design process and its goals. After that we will be discussing about the requirement analysis. Then we will be discussing about different design methodologies. So, when you are looking at a design process, we need to follow a sequence of steps to build a particular product. So, the important goals of the design process are function, what are all the functions we need to provide with the particular product, and how the product should perform, and what will be the requirement of the power. These are the three things we will be looking at the important goals of the design process. So, when you are looking at the process, we will be looking something which is beyond the goals are, one is your time to market. So, time to market in the sense the product should be manufactured with the new features and sold out on the right time. If we are not meeting out the deadline, then we will be lagging in the not committed to that particular time, and we are delivering the product at the later time, then people will find that it may be not a latest product and already the product with that particular specifications are available in the market. So, we will fail to catch up the market. So, because of that, the time to market is the major goal when you are looking at a product should be given in a successful way. And second thing is your design cost. So, the cost of the designing a system should be less, then only you will be in a position to manufacture a product with the estimated budget. So, the third thing is the quality. To obtain the high quality product, the product should be designed with these three factors. One is usability, another one is reliability, another one is correctness. So, this usability, reliability, correctness are the three factors when you are looking at the quality of the product. So, when you are looking at the design methodology, a good design methodology can build a system that works properly. So, a design flow is a sequence of steps to be followed during a design. Some of these steps can be performed either by tools such as compiler or CAD systems, other steps can be performed by hand. So, when you are looking at the different models of designing, first one is the waterfall model, and second thing is your spiral model. Maybe the next one is your successive refinement model, and the embedded kind of system should be coming under hardware and software design methodology. So, these are the different design methodologies which are available when you are looking at embedded system design. But when you are looking at design methodology, always the first thing we have to do, whatever be the model, we have to do first requirement analysis. So, without requirement analysis, we can't go ahead with making a particular product. So, now when you are looking at the requirements, so we have gone, we have gone extensively with the requirements in the previous lectures, but now this is actually a different kind of information in a different perspective we wanted to give you regarding the requirement analysis. Here the requirements are informal descriptions of what the consumer wants. So, the overall goal of creating a requirements document is effective communication between the customers and the designers. So, the types of requirements are, one is functional requirement, another one is non-functional requirement. So, the functional requirement states what the system must do, whereas the non-functional requirement can be other attributes, which is including the physical size, cost, power needed, design, time, reliability, design time, reliability, and many other factors. So, these are all comes under the non-functional requirements. So, when you are looking at the analysis, which will be the requirement analysis is always looking at the first thing is correctness. Correctness is nothing but the requirement should be described what the customer wants. So, exactly we need to find out what the customer wants, which is nothing but the correctness of that particular product. The unambiguousness. So, the requirements must be very clear. We should not say that hazily this is what they want. We have to give a single statement what is their requirement. Requirement should not be said in a fuzzy way. That means the unambiguity should not be there when you are specifying the requirement. And completeness, that means all the requirements should be included. Whatever be the requirement the customer given, all the things should be included, so that the completeness should be in the product to be developed. The next thing has to be considered for requirement analysis is verifiability. So, each requirement should be satisfied. So, whatever be the requirement they have given, that should be satisfied. And consistency. So, one requirement should not contradict with other requirement. So, it should maintain the consistency. Then modifiability. So, requirement document should be modifiable in case of changing the requirements. See, we have done the analysis at one time, maybe when we are going for implementation, by the time the requirement is slightly changed, then we should be in a position to modify our documents, so that the system should accept what is the modification we are doing it, that can also be incorporated in the product design. So, modifiability with respect to requirement document should also be included in the requirement analysis. And traceability. So, this is very important when you are looking at the requirement analysis. To trace backward from the requirements to know why each requirement exists, and to trace forward from documents created before the requirements to understand how they relate to the final requirements. Whatever be the functions they have given, if you are implementing it, what way it satisfies the final requirement of the customer. So, that traceability should be there, and to trace forward to understand how each requirement is satisfied in the implementation. So, when you are looking at a product, we should be in a position to understand that is that all the requirements given by the consumer is satisfied during the implementation, that has to be traced. So, to trace backward from the implementation to know which requirements they are intended to satisfy. So, these are the traceability when you are looking at your requirements. So, now we will be going ahead with the different design methodologies. The first one, and it is oldest one, is your waterfall model, where here we will be having with your waterfall model. First is requirement. As I told you, all the methodologies which is first it will be looking at requirement analysis. From there onwards it will build all the system. So, the first one is requirement analysis, then architecture design, then coding, then testing, then maintenance. So, these are the 5 major phases when you are looking at your waterfall model. So, you just see that the requirement analysis determines the basic characteristics which is required by the consumer. Then the architecture design, which decomposes the functionality into major components, whereas the coding, which will implement the pieces and integrates them. So, coding is nothing but you will be making a software coding, maybe waterfall model tells about the software kind of process. So, the software coding is done with different modules, and all the modules are integrated together to make a single product, and that particular product is tested. That means the testing has to be done always, so that the bugs should be removed. Then maintenance. So, we will be system should be entails deployment in the field, and whatever be the bugs it should be fixed, and it is having a hand to upgrade that particular code in product at any time. So, upgradability and deployment in the field, as well as the debugging, all these things has been done at maintenance stage. So, these are the 5 things which comes under the waterfall model. So, this is the flow diagram when you are looking at the waterfall model, which was introduced by Royce. This is the first model which was proposed by the software development process. Here you just see that the same way requirement, architecture, coding, testing and maintenance is done, so that the entire product is maintained. So, consumer requirement is there, based on that architecture diagram is made, and the coding is done to implement all these architecture, and the coding is tested tested at a different condition, so that it debugs all the problems. But when you are deploying it in the place where we wanted to have that particular product, there we have to again we will face some of the bugs that has to be rectified, and we should provide upgradability to that particular product, so that it gets maintained. So this is the basic water flow model. Basically it has been developed for software development process. And here this particular model it follows top down approach. You just see that it goes requirements, then it goes architecture, and it goes coding, it goes testing, and it goes maintenance, and having a slope. So only it has been called it as waterfall model. So it follows a top down approach, and it requires the prior knowledge of the implementation during early design stages. So it is not possible always to know all the details in the early designing stage. So therefore this particular model, waterfall model, is an unrealistic design process. So people are going towards the next design where this will rectify this problems. So they went towards spiral model, where it looks like a spiral. So it starts system feasibility. First they will be looking at the system feasibility, then they will be going ahead with the specification, then they will be going ahead with the prototype. A small model is first built, then an initial system is made. From there we will be finding out that is there any problem is there, it has been rectified again and again. So it goes in a spiral bound. We will be doing it again and again, so that the prototype is first done, then after that it has enhanced to initial system, then some of the problems if it is there, that also has been rectified, and we will be going ahead with the enhanced system. So it gives some information, I mean it gives you some hand to improve the system from the prototype to enhanced system. So this spiral model assumes several model of the system will be built. So here you just see that the whole thing having so many cycles. So because of that we will identify that a prototype is made. After that we have implemented, we tested it, based on that we have enhanced this particular system. Again we find certain things has to be enhanced, again we will be having another enhanced system. This is like developing a version of software with 3.1, then 3.2, 3.3. So whenever we are finding a particular bug, we will be enhancing, fixing up it, we will enhance that particular product, going ahead with the next version. So that way the whole system is getting several models, so that the system is getting refined each and every stage. So spiral model assumes several model of the system will be built. As the design progresses, more complex systems will be constructed. So the requirements, construction and testing phases are part of the each stage in the spiral. So as each stage adds details to the system, the design of the spiral is widened and thus forming a complex system. So any successive refinement designer can understand the system better. So the spiral model is more realistic than the waterfall model because of its multiple iterations. So we will not build the model with only one cycle, we will be going ahead with the multiple iterations, so that the system is developed with the enhanced method. So this is more realistic than the waterfall model. So but spiral methodology with too many spirals may take too long when design time is a major requirement. So if we will not be having so much of time to design it, then there will be a problem when you are looking at this kind of spiral methodology. So people went towards the next methodology where this gets rectified is nothing but successive refinement model. So in this successive refinement model, what they have done over here is, they will specification is given, architecture is given, they will specify, they will architect, they will design, they will build, and they will test it. So when they test it, they find that it is an initial system, they find that something has to be improved. Then they will, based on what we will be looking at as the aspect has to be improved. So based on that they will modify the specification, so that the specification is getting modified based on this particular feedback from this particular initial system. The specification is modified, so that the architecture is modified, the design is modified, we have built a new system, we have tested it. If I am satisfied with that, we will be stopping at over here. If I am thinking that still it can be improved, then the system, what is the specification we wanted to improve, that we will find out. Again the specification is modified, again it goes through the same kind of cycle, like specification is modified, then architecture is modified, design is modified, so that we will build a new system and it will be under test. So when you are looking at a model is successively refined and we will be getting a best model. So that only the system is called as successive refinement model. So when your system is here in this method, the system is built several times, and at first a rough prototype is filled, the prototype of the system is built, and then by refining the system several times a complete system can be obtained. Mistakes can be avoided by refining the system. Therefore, this methodology is useful to the developers who are unfamiliar with the application domain. So this particular model is very suitable to the newcomers to the industry, so that the application domain, if they are not knowing it, but this kind of methodology makes perfect. That means the mistakes can be rectified each and every stage and we will be getting a better models. So refining the system by building several increasingly complex systems allows to test out architecture and designing techniques. So when you are looking at the design technology, I can say that this technology is most suitable for embedded system design. Why? Because as we know, an embedded system is a combination of hardware and software. That means a processor is embedded with a software to suit for a particular application. That is what an embedded system says. So if I am looking at that way, then when I am looking at, I am developing a particular model where it has a component hardware and it has a component software. So because of that, I will be having, first I will be making looking at the requirement, then from there I will be looking at my specification, then from the specification I will make architecture. That particular architecture will have hardware design as well as software design. Then after designing is done with hardware separately, software separately, these two are integrated together and the integrated system is sent under a test, so that we will be making the system. So this flow diagram gives you the architecture about hardware software design methodology. So this particular methodology involves the following phases, which is nothing but requirement, specification, architecture, and hardware and software design, and integration and testing. So the front end activities such as the requirement and specification is required for hardware and software design. For both the hardware design and software design, we need to know what is the requirement, based on that the specification is made. And the hardware design is implemented, the hardware as well as software design are implemented by concurrent engineering with respect to this particular design methodology. So the concurrent engineering is suitable for large systems. So the main goal of the concurrent engineering is to reduce the designing time. So the designing time is reduced very much when you are looking at the concurrent timing. So here concurrent engineering will make that that particular architecture is slightly modified, give you the clear picture about how the concurrent engineering, with the concurrent engineering the hardware and software is made with your embedded system design. Just see that requirement and specification, requirements, and after that specification is made. From the specification we have gone through the architecture, where with the architecture we have two different setups. One is hardware design, another one is software design. Now the hardware design, when I am looking at inside how I will be doing it, is nothing but the hardware design itself is taken another one complete full design, where specification for that particular hardware is taken separately, has identified. Then a hardware architecture for hardware architecture is made. From there each and every block, what way we will be designing it, that means a detailed design of this particular architecture is made. Then each and every block is designed, that means another design cycle. If I am looking at detailed design, there each and every block is given a full detail. So another design cycle is made. Then we will be making it, the same design cycle is made for a different each and every block. It will be done it in the minute level, so that everything is built up. After that it has been combined together, each and every module is combined together to make a hardware detailed thing. Then integration. So when you are looking at different modules, each module is done with one hardware. Now each module works perfectly, but each and every part of the hardware is combined together, so that we will integrate them each and every hardware, so that we will make a hardware product completely. So, that particular hardware product is tested. So, now remember that when you are looking at an architecture, there each and every block is telling you about one function. Each function is done with one hardware. So, each function is again looked at the same kind of way. Specification of that particular block is done, hardware how architecture is done, then inside it how we will be doing it. So, that way the same thing is again each and every module of the hardware is done with the same kind of setup. So, that I will be making one module as one small product. Now, all the things, all the modules with the different architecture hardwares are integrated together. Maybe each module will work separately properly, but when I am integrating all these hardwares together, it may not be working properly. So, because of that, the integration should be done with a perfect way, so that after integrating it, I will be testing it. Is there any problem with the hardware? Then I will rectify. I have to go back, I have to identify where the problem is. Then I have to change that particular specification. Based on that, I have to refine all the other design cycles. Then I will make a product. Again, I will integrate it. I will test it. All the problems with respect to all the bugs with respect to that particular hardware is rectified, and we will be making the system work perfect. So, now the whole hardware part is made perfect, but still that is not sufficient for an embedded system design. So, we know very well the software is also needed for your embedded system. So, the software is taken separately, where what will be the aim of the software, based on that the specification is written, and based on that system architecture is made for with respect to this particular specification. Then we will be making a full module design, which is nothing but architecture diagram with respect to software. That is nothing but a module design. Each module is taken again in a way, the one heading is taken. Based on that the specification is identified, architecture for that particular one is written. So, detailed design of each module is done separately, and one team maybe one person will do that particular module. So, all the modules will be done separately, that may work properly, but when you are combining all the things together, that means while you are integrating together, it may not work properly. Again, we have to go back, we have to modify all the things, we have to find out where is the bug. Each and every person has to look at their module, it has to be corrected. Then we have to make everything is integrated together to make a system properly. If I am thinking that the system working properly, then I should test for the different conditions. So, with the different test cases, the software is tested. We found that it is working, but still it was not over, because the hardware is working perfectly, the software is working perfectly, but we need both the things should work together, so that I will get the product to be working perfectly. So, because of that, I will take the hardware and software after the design, I will take it from here, I will take this, I will take this here. So, hardware and software is integrated together, that means the software is embedded to hardware. Now, I will be looking at whether the system is working or not. If the system is not working, I will identify where the error is, whether it is in hardware or it is in software. If I am finding it is in hardware, again I will go over there, I will find out that whether the specification has to be modified to rectify that particular bug. Again I have to go through the whole cycle to make it, this hardware should work properly. Once it works, again I will come over there. Then these two is getting integrated, I will go for a system test. If I am finding it software is not working properly, then I have to go to this particular design, I will go over there. Based on the bug, I will find out, I will change my specification. Based on that, I will be modifying the whole process, so that I will make the whole software is working perfectly. Then I will brought it over here. Now, hardware and software is integrated together, again I will check it. So, that way it goes in a successive process, again and again I am finding is there any problem is there. Based on that, whether it is hardware or software, every time I am refining this particular process, so that the whole system should work with the different test cases completely. So, this is the way an embedded system is designed, with the help of hardware design as well as software design separately in concurrent engineering methodology. So, when you are looking at concurrent engineering, in order to reduce the time, hardware and software design phase implementations are carried out separately as well as concurrently. So, the hardware and software can be done parallelly with the different groups, so that the time consumption is less. The same group will not do both the things together, and they were doing it separately hardware, they are doing it software separately, but parallelly they are doing it, in the sense the time taken will be reduced. Maybe it takes drastically half the time is reduced. So, approximately half the time is reduced, and the result obtained in hardware and software design is brought to the integration phase. So, finally the system is tested in system test phase. So, this methodology brings interaction between the designing as well as the manufacturing team, since little interaction is required while designing large systems. When you are looking at concurrent engineering, where the efforts are compressed of several elements which are nothing but cross-functional teams, concurrent product realization, incremental information sharing and use, integrated project management, yearly and continual supplier involvement, and yearly and continual customer. So, these are the things which will be a part of concurrent engineering efforts. So, the cross function, when you are looking at cross functional team, where it includes the members of the different functionality teams from various disciplines. Each member is from various disciplines, maybe from hardware side, maybe from software side. So, depends on the function, different groups will be there, and maybe they are from a different discipline. So, that which has a multi-disciplinary members which will be available over there in the group. Manufacturing, hardware and software design is done, then marketing and so forth. So, all those things is done at this cross-functional team. So, the concurrent product realization. So, in this, these activities are the heart of the concurrent engineering, where doing several things at once, such as designing various subsystems simultaneously, is critical to reduce the design time. So, the design time is reduced drastically when you are doing it at different groups and combined together to produce a product. And incremental information sharing and usage. So, it helps to minimize the chance that concurrent product realization will lead to surprises. As soon as new information becomes available, it is shared and integrated into the design. So, the cross functional teams are important to the effective sharing of information in a timely fashion. So, when you are looking at the integrated project management, which ensures that someone is responsible for the entire project. So, that responsibility is not avoided with respect to once one aspect of the work is done, and yearly and continual supplier involvement. So, which helps to make the best use of suppliers' capabilities. So, yearly and continual customer helps to ensure that the product best meets with the customer's needs. So, in this lecture, we have discussed about design methodologies, and we have discussed about the requirement analysis as well as the design process of its goals, and discussed about different design methodologies. With that, the concurrent engineering model, concurrent engineering used model, which will be very useful when you are looking at embedded system design methodologies, because it looks at why we are saying that way is, it looks at hardware design as well as software design, and it has been done in a successive refinement way. So, because the successive refinement makes the system perfect, people are going ahead with that kind of method. Concurrent engineering with the successive refinement model is best suitable for designing embedded systems. So, in this lecture we have discussed different methodologies as well as the design process and the requirement analysis. Thank you.